Hello everyone. In this tutorial we are going to learn about comparator using OPAmp IC741. So what is a comparator? A comparator basically compares two voltages or currents and indicates which one is the larger one. In this tutorial we will first learn some basics of OPAmp and then we will see our topic comparator, and at last we will see applications of comparator. You can jump to any topic following the timeline. So what is an OPAmp? An OPAmp is an operational amplifier. What is an amplifier? An amplifier is a device which increases the strength of the input signal given to it. For example, a loudspeaker. The amplifier present inside the loudspeaker takes sound as input and converts it into a higher magnitude sound. Why this amplifier is called as operational amplifier? The word operational signifies here that this amplifier can perform many complex and mathematical operations like differentiation, integration, addition, subtraction, and many more. One of those applications is our comparator. What is inside this OPAmp IC741? This is the internal structure of the OPAmp IC741. There are 22 transistors present inside this IC. But what is the size of this IC? This whole complex circuit is packed inside into a small IC which you can keep on your fingertips. Could you believe this? This whole large structure is packed inside in this small IC. Whew, great technology. Let us not talk about this IC741. This IC is an 8-pin IC, out of which pins number 7 is for positive supply, pin number 4 is for the negative supply. There are two input terminals. Pin number 2 is known as the inverting input and pin number 3 is known as the non-inverting input. It has one output terminal at the pin number 6. This is the symbolic representation for this OPAmp. The pin number 2 is the inverting input, pin number 3 the non-inverting input is shown here, pin number 7 and 4 the power supplies are shown here, and the output pin terminal is shown here. The important point to be noted here is that the inverting input is denoted by the negative sign and the non-inverting input is denoted by a positive sign. Remember this. Now let us see the open loop and closed loop configuration of OPAmp. This is the open loop configuration and this one is the closed loop configuration. The only difference between both this configuration is this feedback resistor RF. In open loop configuration there is no feedback, while in closed loop configuration there is a feedback resistor. Let us see the open loop configuration in detail. The gain of the open loop configuration is very large. It is about 2 into 10 raised to 5, that is about 2 lakh. So suppose you are applying an input of 1 volt, then the output voltage you will get will be, yes, 2 lakh volts. Could you believe this? But this is not the case. At such high output voltage, the OPAmp will get burned. So, how much is the output voltage? For that, we have to see the concept of saturation region of OPAmp. Whenever the output voltage of OPAmp is greater than or equal to the supply voltage, the OPAmp enters saturation region. For our IC741, the saturation voltage is 90% of the power supply. So suppose you are applying the power supply of 15 volt, then the saturation voltage will be 90% of 15 volt, that is 13.5 volt. Check out this graph. Here this sine wave is our input signal. The expected output voltage signal is also a sine wave with higher amplitude, but here you can see the output signal has got clamped at this plus VSAT value. Similarly, for the minus VSAT level also the voltage gets clamped. In short, you cannot get output voltage greater than the saturation voltage of the OPAmp. Also, please note that when OPAmp is operated in saturation region, it is said to be operating in non-linear mode. So how can we use our OPAmp as comparator? For that we have to operate the OPAmp in open loop configuration, that is in the non-linear mode. That means that the output will be in the saturation region. So the formula for output voltage in open loop configuration is given by this equation, where V plus is the input signal at non-inverting input and V minus is the input signal at the inverting input. So suppose you are having 6 volt input at non-inverting terminal and 5 volt input at inverting terminal, then the difference here will be 6 minus 5, that is 1 volt gain in open loop configuration of OPAmp. It is quite large, we have seen that before. So anything multiplied by here will give us output voltage in saturation region. So we will get the output as plus V sat. Now let us reverse the condition. Let us apply 6 volt at inverting input and 5 volt at non-inverting input. So this equation will become 5 minus 6, that is we will get minus 1 as the difference, and by multiplying it with the gain in open loop configuration we will get the output as minus V sat. So this is the basic principle of using OPAmp as comparator. Input signal at non-inverting terminal is greater than the input signal at inverting terminal, we will get output as plus V sat, and whenever the inverting input terminal has higher voltage than the non-inverting, we will get output as minus V sat. So this is a comparator circuit where I have applied a sine voltage as input signal and a DC 0.5 volt as the reference signal. This sine wave has an amplitude of 1 volt. So let us check what is the output. So here you can see I am pinning on the input signal. You get a sine wave here. Let us check the reference signal. You get a 0.4 DC volt here. Now let us check what is the output. Here we go. The output is a plus Vsat minus Vsat square wave. So here in the graph you can see whenever the input voltage goes higher than the reference voltage, we get minus Vsat as the output, and whenever the input voltage is less than the reference voltage, we get plus Vsat as the output. Comparators can be used as window comparator. They can be used for zero crossing detector. They are also used in voltage level detectors.